activity 2. All right. So basically, it takes the it looks at the systems of equations, the linear ones, the inequality ones, the regions, the ones you were just working on, and it applies it. All right. So the one I'm going to give you is an example where we have some a cereal, and I just called it a fruit pack. And here's the whole story behind it. So, a nutritionist is designing a meal for somebody who wants to improve their nutrition, and they want to key a certain number of minerals. So they're going to change their breakfast to a certain cereal and a fruit pack, which has like some strawberries and bananas and pineapples and yummy things like that. So the cereal contains these minerals that are important. So it has iron. They want to have a little bit more iron. So they want to meet, or excuse me, it has 90% of what is called the RDA. Now, if you're a nutritionist or if you understand that RDA stands for the recommended daily allowance of certain minerals, so then what you take in, the recommended daily allowance, of course you can exceed that. The cereal that they're going to give this person, it contains 90% of the iron that person needs. So the RDA is nothing to get excited about. It is just that's what the unit is. So if you look on a nutrition label, it will say RDA. Well, that's the recommended daily allowance. So if you're getting 90% of the iron, that means all you got to do is eat something else that has 10%, and you've met your requirement for the day of iron. Some people need more or less. It's just an average. It also contains, and it contains other things too, but they were keen on these minerals. Magnesium, which I'm not even going to attempt to spell unless some of you know how to spell magnesium. M-A-G-I-S-I-U-M. N-E-S-I-U-M? There's an E right here? Yeah. Nice! You guys are great spellers. Okay, magnesium. And it has 15% of that, so it doesn't have a lot of magnesium. You're going to have to find another magnesium source. And then the other one is, potassium. I think I can do better with potassium. All right, and let's see, that has 7%. Not a lot of potassium in there. Okay. The other important item is the number of calories. I'm going to put that in red because I want to separate that out a little bit. And the number, now this is just plain dry cereal with no milk or anything. Has 190 calories. All right. Oops, boo. Okay. So then if you look on the bottom of your activity, well, not in the bottom, but in that little table, it says fruit, apples, and pears, it says, and it gives you vitamin C, calcium, calories, and so forth. All right. This one's actually going to be a little bit harder. Okay. Then the other thing is this fruit pack here. And it contains 10% iron, 9% magnesium, and 20% potassium. Okay. So I'm going to stop there just so you can kind of write that down and get it. So those are the two things you're going to take. All right. They're going to concentrate on. Again, it can get more complicated when you include milk and you maybe include something else. But I'm trying to keep it relatively simple to give you an idea of where you would use this. So, here's what the nutritionist is desiring for this person to do. They want him to intake these things. They want him to get at least 70% of the iron, 30% of the magnesium, and 40% of the potassium. So that is what this nutritionist wants this person to do as far as eating those things. Okay? And it's going to be the same thing in yours. It's going to tell you you want to have at least, or however it's phrased, these things. So what we want to do now is write equations for these items. Now these are called, and I'm just going to call you, let you know, these are called constraints. All right? And each constraint is going to be an inequality. So let's do that. Let's write inequalities for these. So first I'm going to start with the iron. So I need to set up a variable for cereal, and I need to set up a variable for fruit. So what should we pick for cereal, X or Y? And fruit would be, okay, so now all I'm going to do is take each one of these categories of items. So the iron, and I'm going to combine those into an equation. So I'm going to go, let's see, I get 90% from cereal, so I'm going to go 90x plus. I get 10% from the fruit. Y has to be at least. So that means I'm going to have an inequality there. So the question is, though, would that inequality be a greater than, or would it be a less than if I want at least? What do you think? Greater. So I'm going to go greater than or equal to 70. Now, if you have a serving of both of these things, you've already maximized your RDA, okay? Because you'll have 90 plus 10 is 100, and you will exceeded the 70 already. But that's only one constraint. We got to go do the other ones. So now let's pick.
Can you go back up?
Where do you want me to go?
The bottom where it says 90.
Sure. Yeah, if I'm going too fast, just say, hey, stop for a second.
Okay, thank you. Got it. Thank you.
Okay, no problem. Let's go with this light green here. Maybe we can see this. So now we'll go magnesium. So that's magnesium there and magnesium here. So this one's going to be 15x for the cereal. 15x plus, I get 9 from the fruit, so that's 9y is greater than or equal to, I need 30%. So see there, I would have to have more than one serving because 15 plus 9 is 24, and I'm about 6 shy of reaching that 30%. All right, now let's do potassium, sure. So we have 7% potassium here, 20% potassium here, and I need 40. So I'm going to go 7x plus 20y, I think that's what it was. 7 and 20, yep. It's got to be greater than or equal to 40. Okay? So there's my inequalities. Now, in your activity, I said only concentrate on the first quadrant. The reason for that is because you're not going to eat negative amounts of food. All right? So we don't even have to worry about any other quadrant but the first one. Because, again, x and y have to be positive values. So I put these down also because, again, I can't have negatives. So this is all my constraints.
How do we get x 70 and y 70?
This is not 70.
Oh.
This is greater than or equal to and greater than or equal to zeros.
Oh.
Because you can't have negative amounts of food. So this is a pretty complicated little linear, this is called a linear programming problem. All right? So your thing, so on yours, you only have 2 items to worry about instead of 3. We have 1, 2, 3 equations. You're only going to have 2. All right, so this one's going to have 3, but we'll look at it anyway. So how do we solve these inequalities? What were we just doing to solve them? What do we got to do? No. How were we doing it in 4.5?
We like subtract. Substitution.
We graphed. Remember? We graphed and shaded. Okay? So that's what we're going to do. We're going to have to graph this stuff and shade it. Okay? So, can we graph them in the form that they're in right now?
No.
What do we got to do? Solve for y. So I'm going to take the orange one here and solve for y. So we're going to go like this, and we're going to solve this for y. Okay? So I'm going to move this over to here, move this over to here. 10y greater than or equal to negative 90x plus 70 divided by 10 divided by 10. Here's my equation. Divide by 10, divide by 10. Okay? Now, like I told you, what I would do is graph this in decimals because it makes it a lot easier for you to find the answers. Okay, now I'm going to take the second one, do the same thing. I got to solve it for y. So I'm going to move that 15x over, get rid of it, move it over. 9y, negative 15x plus 30 divided by 9, divided by 9. And when I looked this up last night, this is I just picked a serial, and these were actual numbers because I like to use actual stuff. Okay? I don't like to give you fake information, like fake news. Okay? So I want to give you the real information. All right? Okay, so here's that one. And here's this one. Now we got one more to go. So 7x plus 20y is greater than or equal to 40. Subtract 7x. And divide by 20. I'm just going to do that for that one. Okay. There's my equations. So now I'm ready to go into, Desmos and graph them. I could graph this by hand and get a pretty reasonable sketch. I don't know if I want to deal with 30 divided by 9 too badly, or really I want to mess with, 70 divided by 10 is not too bad. And some of these other ones aren't too bad. Okay? But if you already know how to graph these things anyway, so let's just make it easy on ourselves. All right. You got them? Okay, because I got to flip this off here in order to go into Desmos. Okay, I don't need these anymore because I'm done with that. Okay, so I'm going to type these in. I'm going to type them in just as inequalities. So I'm going to go y, my first one, okay, is greater than or equal to negative 9x plus 7. So there's my first one. Y greater than or equal to negative 15x. Oops, not quite. Back up. negative 15 divided by 9x plus 30 divided by 9. Okay, there's the other one. Now you can start to see a region form here. Y greater than or equal to negative 7 divided by 20 x plus 2. Okay, so there is all three of them graphed. Now remember, I'm only interested in the first quadrant. So I really don't care what's happening back here in this white area, because that's not where my answer is. Okay? So I have to figure out, well, where's my answer at? What area? Because I got a lot of colors here. Okay, I've got orange, green, purple. I don't even know what that is. And this color here. So let's see. This is shaded above, above, and above. So where's the area at? This thing right here, huh? Okay, so that whole thing there is my region. Okay? All this stuff out here is where my answers are. Okay, so anything out here is going to be an answer to my problem. All right, so for example, 5 and 4. 5 of the cereals and 4 of the fruit right there. That point, 5, 4, that's an answer. So is this one. 4 and 3, and 3 and 2, and 2 and 3. I mean, there's a lot of different answers, okay? But there's one more wrinkle to this problem, and that is this nutritionist wants to minimize the number of calories that you take in. So, if we go back to the calorie thing, how many calories does the 190. I think I forgot to tell you the calories for the fruit. It's 62. So the calories for the cereal was 190, and the calories for the fruit is 62. Now you can't see it, but I'm going to write that down on my thing here for calories. I'm going to write down calories equals 190x plus 62y. Okay? Calories equals 190x plus 62y. Now what I'm going to do, and I don't want you to do this, I just kind of want you to watch what I'm going to do up here. I'm going to put in what is called a slider to give you an idea of what we're looking at here. Y equals, let's see, y equals c minus 190x. Okay, so I'm going to go parentheses c minus 190x divided by 62. Enter. And I add c. Okay, this black line here represents this calorie line. So if I move this, you can barely see this line here. So I'm going to take this number and make it bigger. I want to make it about 100. Step it by 10. So 0. Okay. Now this line's going to move, okay, and we want to minimize. I need to make this even bigger. All right. So right here, do you see how it's right at that intersection point of that region right there? That's the minimum number of calories. That's the answer. Okay? This one here is going to be a little higher. This one here, way up here, is going to be a little more, and this one would way exceed it. So, what we need to do is find these corner points. That's why I didn't want to leave Desmos. I want to find these corner points. So, to find the corner points, if I'm in Desmos, all I got to do is touch it. And it says 0.5 and 2.5. Okay? So I'm going to write that corner point down as 0.5 and 2.5. Then I need this corner point down here, and it's 1, and I'm rounding it a little bit, and 1.6. Okay? Then I need this corner point way up here. Okay? And that's 0 and 7. And then I need this corner point way down here. And it's 5.7 and 0. Alright. Now I'm going to get rid of this and show you what I did here. Alright. So here's my calories equation. I solved it for y here so I could do it, because otherwise I was going to have struggle with my head. Solved it for y. But here's my corner points. So my little region looked like this. So I had a big steep line. I had a line coming this way. I had a line coming this way. Oops, I think I'll make that one just a little bit different. And a line coming this way. So, point here, point here, point here, and point here. And this was all my shaded stuff. Okay? And one of these points is going to be my minimizing of calories. So, I'm going to take my calorie equation. I'm almost done. What was my calorie equation again? What did we write for that? 190x plus 62y. And I'm going to check every single one of these points to see which one has the minimum number of calories. So I'm actually might get some help from you guys, because I don't want to have to bounce back and forth. Alright, so I need, if we can get somebody to try the first one here, which is 5.7, comma 0. So 5.7 is going to go in for x. So if they would just take their calculator and figure that out for me, that would be great. Okay, then I need 0.5, 2.5, and put that one in there. I need that number. Then I need, my other corner point was 1 and 1.6, so that would be 190 times 1 plus 62 times 1.6. And then my other final corner point is 0.7, so that would be 190 times 0 plus 62 times 7. Okay? So I'm taking each corner point of that region that I had. I don't care about all those other points. They don't mean anything. They're not minimizing calories. It's the ones on the bottom that are minimizing calories. So I want to know which one of these is going to be the right answer. Did anybody get the green one figured out here with a 5.7 times 190? How much is that?
1,083.
1,083. How about the red one where I have 190 times 0.5 plus 62 times 2.5? Did anybody do that one? 190 times 0.5 plus 62 times 2.5? How much is that? Yeah. 250? Okay. 190 plus 62 times 1.6? $190 plus 62 times 1.6? To what? 289.2. Okay. And the last one, 62 times 7, because 190 times 0 is 0. How much? 434. Okay. Which one is the minimizing of all the calories? Green, red, purple, or black? Red is. There's your answer. So your answer would be to have 0.5 servings of cereal, because it was X, and 2.5 servings of the fruit. All right? So when you do yours, remember it's going to be less complicated because you only got 2 equations rather than 3. Graph it, find the region, and then look at those corner points that make up the region. Don't worry about the other stuff because that's not important to this particular problem that you're solving. Find those corner points. Now, let me go back to this a little bit. If we didn't have this nice technological, and we needed to find this point between these 2 lines, how do you find that intersection point with 2 lines? What did we do to do that? Last week.
Did like substitution.
Substitution or
Elimination.
elimination. Okay? So, before there was a lot of technology, that's how they would, somebody might have to write a program in a computer or something, or code it, or to find this, a solution to a system of equations. Here, elimination, substitution, and substitution. Okay, so there are applications for some of this stuff. All right, and this is just this one. And you can have a problem like this with a whole bunch of different equations. All right, and having to find different solutions. Okay, they can get pretty complicated. So that's how you do this. I think if you follow this little video here, I'll put it up there, it'll help you. If you use the chart, I broke it down into a lot of sequence of steps. So do this, do this, do this, where I just kind of went through it. So I think yours will be quite a bit easier than that. Okay, you might be a little overwhelmed, but once you get going, it'll probably be okay. Any questions on it? Okay, I'm saving it right now.